Hello, it's Kamilescu and welcome to Mixersinside. Today we'll again talk about making of a DJ mixer, this time part 4, component selection. Today we'll talk about selecting the components for our design. Previously we were talking about electronic schematics. We were trying to understand the circuitry, the schematic, and we were just looking at a representation of components on the schematic, but we didn't know what particular components we'll use in the design. And to make it work, to make the design work and to make it elegant, you want to produce a printed circuit board with all the elements here. But before you make this board, and on the next part we'll talk about printed circuit board design, but before you design the board, you must find all the components you want to place on the board, because you want to know the component sizes to just fit in the board and to make a nice layout. So yes, component selection. Where to begin? I think that good idea for start will be just categorizing the components to see just where we're at. So first of all, components we can classify for two groups. We can classify active components. Active components are diodes, transistors, integrated circuits, and I will talk about the qualities of active components a bit later. And then we have passive components, and those are resistors, capacitors, inductors, potentiometers, transformers. And yes, I will explain a bit later what's the real difference between active and passive circuitry. Also, we can classify components for two groups. The first group is surface mount, and here we are talking about the technology of attaching the parts to the board. Surface mount parts are attached to the board and are just soldered to the surface of the board. And then we have through-hole components. It's a bit older technology, and here to solder the part to the PCB, we have those legs here. Every through-hole component has its leads, and those leads go just through the board. That's why we call it through-hole. So essentially, with through-hole components, your board needs to have holes to fit the components. Just take the leads and just place them through hole and then solder them. And then also we have classification. Components can be discrete, and components can be integrated. And what's the difference between a discrete component and integrated component? The difference is that discrete components have like one discrete component. In this case, I'm showing a resistor. It's just a resistor, nothing else. This component is just strictly a discrete resistor, and its role is to just give resistance to circuit, and that's all. And integrated circuits, integrated components are just miniaturized circuits that are fit in the chip. So integrated components are just many components fitted in the chip. As you can imagine, it can bring some limitations, and when the integrated circuit technology was starting, I don't remember, but it was like back in 70s or 80s, I think maybe more 80s, it was a huge struggle to pack all the components you need to the chip, and also to maintain good quality of those components inside the chip, because it's a whole different technology. It's just the components in integrated circuits are just etched on a silicon wafer, and those are just those are very small components, like I don't want to lie, but it's about like nanometers or something of this order. So you can imagine that those components are much smaller than discrete parts. And first, humanity was just struggling with fitting it in the chip, but also fitting the components inside the chip and fitting the components very close to each other and dense brings some advantages. For example, the thermal coupling of elements is better, and many circuits need good thermal coupling. They need to maintain this close temperatures. When you have two components and their temperature varies, it sometimes problem. So you need some thermal coupling. So those integrated circuits help with things like, for example, thermal coupling. And I mentioned that in the 80s it was a struggle to pack all those components to chip. Now the technology is much better, and integrated components have just insane performance, and audio is just one of example where you can use integrated circuitry. But for example, with integrated circuits you can measure some for example, seismic stuff. Yeah, you can detect very small movements of I'm not an expert in this, but like small movements of tectonic plates to maybe predict earthquake, so integrated components nowadays have so good performance that you with those components you can make a measurement gear that can measure very delicate signals, much more delicate than audio signals. So yeah, what I want to say is just technology is changing, and we are just getting better also with integrated circuits. And I want to again speak about this debate about difference between discrete circuitry and integrated circuitry, because it's very interesting topic, and there are really no very obvious answers in this field. You can't say that like discrete is better and end of discussion, or you can't say that integrated is better and end. In audio and basically in all electronic fields, but also in audio, people sometimes want to use discrete circuitry because it's it gives you more control. As I mentioned before, integrated circuitry is just components fitted in the chip. So when you get the chip, when you buy the chip, you don't have really control what's going in the chip. You can't change the values. Someone that was working on development of this chip, and before it went to production, someone made made a design, and you just buy this design, and you can't really change it. And with discrete circuitry, you have just full control. So here I just compared discrete circuitry and integrated circuitry in the way that if you want to get, when you want to have full control and just go with your imagination and do whatever you want and have every parameters under control, you may want to go with discrete circuitry, because like we see here, this guy has quite funny suit, but it's you know, it was his individual decision and he had control. And here integrated circuitry, I compared integrated circuitry to going to big market with very large variety of suits you can get. Probably in this market you'll find perfect suit that you need, or very close to perfect, but essentially in this market it's highly probable because of the choice that you will find just exactly what you need, but still you are just buying a ready solution and you can't really do anything about it. And with discrete circuitry, you can do some more precise tweaks. The question is do you really need it? If you are aiming for just transparency and high performance, I would say that technology nowadays offers so good chips that you probably would go with just integrated circuitry. But if you want to have more control, and for example, as we saw, because on this YouTube channel I also spoke about DJ mixers, and I showed some DJ mixers. Some of them had discrete circuitry, and usually when we saw mixer with discrete circuitry, it had higher distortion, higher THD, but just different sound signature than circuits that used ICs. So with this using discrete circuitry, the designer of the device could decide that, okay, I like the fact that I have high distortion for whatever reason, but the reasons are just solid. In DJ world, you don't necessarily need clean sound. Some people are just fans of, you know, saturated, hot, warm, fat sound. And if you want to tweak the circuitry to achieve this warm, fat sound, probably it would be easier to do it with discrete circuitry because of control. I hope it's clear, and if you have something to add, feel free to comment, because it's a very, very interesting topic, and I'm really keen to discuss about this. So I was saying about technology progress in terms of integrated circuits, that they are just going better and better. But what I want to also comment is that technology progress is also the thing I mentioned before, the mounting, the way of mounting the components. So THT, through-hole technology versus SMD. What I observed in rotary mixer community, or in general in hi-fi community, is that many people are just still afraid of SMD components, because one very obvious thing, and it's just not very technical what I'm saying now, but those SMD components look more like, you know, digital, technological, you know, like modern, and people have a very warm people have very warm memories of vintage gear. So many people, when they are thinking about how good sounding gear looks like, they usually think about some maybe tube amps or some older vintage stuff, and this vintage stuff used those components in through-hole technology. And the truth is that the SMD components are just those are the same solutions, but the way of mounting is just different. They are not through-hole, they are just mounted on surface, and also the size of components, because also when you mount something on the surface, you don't have to have large leads to carry them through the board. You can have much shorter leads when you deal with SMD components, and this technology also allowed to do some miniaturization, and essentially you get just the same component with the same performance, but it's smaller, and it can have some benefits. For the first benefit is less parasitics. This is a very broad topic, and it's more advanced. It's not a beginner type of knowledge, but essentially when you have smaller leads from the component, you can achieve less parasitic inductance, and essentially you can just have less side effects, let's say. But if you want to really dive deeper into it, I recommend just, Googling electronic component parasitics or stuff like that. Later on, I will also tell you about a nice book that describes this. And also, what's nice about this SMD technology and making design more dense and making the traces shorter is that the current loops, because current flows in loops, and the loops are much smaller, and thanks to the smaller area of circuit, this circuit is less prone to interference. So when we speak about higher immunity to electromagnetic interference, you want to use SMD components, keep the loops small, and basically squeeze the design. Thanks to this, it will not only receive less interference, but also in some cases emit less interference. So yes, I think that this technology progress is really significant, and thanks to SMD components we can achieve better stuff, and there is really nothing to be afraid of. And here I don't want to offend anyone, and I don't want to make it a topic for a battle. It's just my opinion, but what I observe is that in a very there is a huge amount of people in the audio, hi-fi, mixer, DJ community that have, as I said before, that have like this more warm memories of vintage stuff, and they just think that the perfect gear is first discrete, then that the components are true whole, because they saw it on in some tube amps or vintage equipment. Also, the very some people mentions point-to-point wiring, and this is also interesting topic, because it's not accident that some gear has point-to-point wiring, especially tube amps, because thanks to this you can keep the connections reliable and strong. But mostly if we are speaking about benefits of point-to-point wiring, we speak more about larger power amps, not exactly preamplifiers and mixers. So point-to-point wiring don't necessarily bring some benefits. For example, one of the benefits of point-to-point wiring is that when you have a mechanical connector, and through time the contact may be a bit worse, and when you wire something like point-to-point without a connector, it can be more reliable through years. But this is just very not really necessary. But essentially what I'm trying to say, that many audiophiles say that proper gear must be big, use big in size components, and the looks should like recall the vintage stuff. And I really can't agree with this, because nowadays the SMD technology is very wide. You can buy very high quality parts in SMD technology, so those circuits doesn't look like those classic vintage circuits. They just look more modern, but their performance is as good as the bigger stuff, or sometimes better, because of the reasons I said to you. For example, smaller loops, parasitics, but there are also some more benefits. So yeah, those terms I would say that are like people that are trying to say that those solutions are the best. I think that they're a bit biased by some technological nostalgia. But I'm also very open to discussion. I'm really keen to discuss about this. So if you recall any advantages of this type of technology, of the technology of previous century, please tell about it, and I'm very interested to hear out and also to discuss. So let's get back to speaking about components, and I want to say a bit more about what are active components. And active components are essentially components that require external power source to work. For example, a diode to conduct must be polarized. A transistor also needs polarizing voltages for current to flow, and essentially needs some external power. So yeah, those are components that need power supply, but thanks to this that they are consuming power, they are used for amplification of voltage and current. Thanks to those components, we can amplify the signal, and this is very useful. And what I want to really underline is that active components and the way you use them, active component selection, have huge impact on linearity and sound signature, and basically on on how your circuit sounds. And on the other hand, we have those passive components, and the main difference between active and passive components is that passives don't have to be powered. They just work as they are. They don't need external power source to work. And the main role of passive components, because active components, as I said before, they amplify voltage, current, and components that are passive are more for signal conditioning, so like setting the conditions. For example, thanks to resistors, you can you can bias the transistor and choose operating point of the transistor and decide on what region it works. If you bias the transistor, you can get a more linear response or less linear response. You can decide about this by placing resistors in some places, limiting the current. So yeah, passive components are basically to condition the signal. Other example of conditioning the signal are, for example, capacitors in filters. When you have EQ circuit, for example, and when you want to just make a simple low-pass filter, and you want to decide what will be the cutoff frequency of this filter, you you need a certain value of capacitor, also a resistor, but a resistor and capacitor together will form this filter. So thanks to passive components, you can do such things. And passive components can have impact on sound signature, but I would more say that passive components can limit the performance of the circuit, can limit the performance of active circuitry, and this is something worth considering, because, for example, when you browse the datasheet of an op-amp, for example, and it's the manufacturer states that this op-amp in these conditions have, for example, minus 120 dB of THD, and you can actually you can't take it for granted. You can't say that, okay, if manufacturer state that this THD is minus 120, I will use the chip and achieve the same figures. And unfortunately, no. With bad selection of passive components, you can limit the performance of this circuit. And here I have an example for you about limiting the performance. I took it from a note by Texas Instruments analyzing their newest chip that have some thin film resistors on board. So essentially, they compared two very similar circuits, and the difference between those circuits was mainly the material of the resistors. And here in this graph you can see that by using external thick film resistors, and thick film resistors have worse performance than thin film. So when they used thick film resistors, you can see that the THD plus N, so distortion plus noise versus frequency in the frequency band, it was higher than when they used thin film resistors. So as you can see, the performance of the circuit was limited by using not suitable resistors. Then they took thin film resistors. Those resistors were probably first of all less noisy, and also those resistors were more stable in terms, for example, of temperature coefficient, and I will mention about temperature coefficient also a bit later. Yes, I promised you to give you some more research on passive components. This is the book I recommended in previous episodes, because I want to also mention that there was, in this Making of the DJ Mixer series, there was a whole episode dedicated to tell you where to gain knowledge from. So getting back to it and recommending you some resources, I want to once again recommend you this linear circuit design handbook from Analog Devices. It's available, it's wonderful, it's available completely for free. The PDF is just for download from Analog Devices website, and you have just tons of knowledge, tons of research about various things. And here we have a whole chapter. Chapter 10 is entirely dedicated to discuss passive components. Also, you have here, as you can see, here you have chapter 10.10 deals with parasitics in capacitors, and here in the next section, section 10.2, you have also resistor parasitics. Yeah, you can learn about what's parasitics, for example, from this book. And yeah, so we categorized the components. We said that those are active and passive. They can be surface mount or through-hole. But what components are good for audio? Because in this series we are talking about making audio gear. So what I want to answer, how I want to answer is that it depends on the specific part of the circuit, because in different parts of the circuit you will use different components. And I want to give you some examples. This is the first simple example. This is an electrolytic capacitor. It's a very common part. And this kind of capacitor, electrolytic capacitor, is just perfectly fine for power supply filtering, where you need just a huge capacitance. For proper filtering of the power supply, you sometimes use values like hundreds or thousands of microfarads. So yeah, pretty big values. And here in power supply filtering, when you want to smooth out the voltage, this is just perfect place for an electrolytic capacitor. But when you want to make a filter with electrolytic capacitor, for example, a filter that I mentioned before, a low-pass filter, and you want to set a precise time constant to decide what's the cutoff frequency, the electrolytic capacitor is just terrible. First of all, electrolytic capacitors cause just audible, maybe let's not say audible. Electrolytic capacitors cause distortion in circuits that is possible to measure, so it's measurable, not necessarily audible, but there were some blind tests, and you can also research this topic. But yes, electrolytic capacitors, it's proven that they are not linear, so in filtering application they would be terrible because of non-linearity. And other thing is that mainly electrolytic capacitors have very wide tolerance. When you buy a certain value of electrolytic capacitor, for example 1000 microfarad, usually manufacturers specify that its tolerance is about plus minus 20%. So if you buy electrolytic capacitor with value of 1000 of microfarads, and you get, when you measure this capacitor and it turns out that it has 800 microfarads, it's within the specification, it's within the tolerance, but it's just those kind of tolerances are unacceptable in filtering applications in the signal path. So yeah, this is an example where it just depends what part of the circuit we are talking about. Another example, also capacitor. Here we have a polypropylene film capacitor. It's MKP capacitor. When you look at the photos of HiFi gear, it's very common to see this kind of capacitor, especially red, because there's one very popular manufacturer of those capacitors. It's called Vima, and this manufacturer indeed makes some quality capacitors. So getting back, this MKP polypropylene film capacitor is ideal for filters in the signal path. So these applications we are discussing with electrolytic capacitor, with this low-pass filter. The low-pass filter is just an example, but yeah, when you want to design low-pass filter, you want to be just precise with the cutoff frequency, and also you want to maintain low distortion, because you don't want the filter to introduce any distortion. Or maybe you want, but ideally when making a proper low distortion, maybe let's not call it proper, but when making low distortion gear, you want to use polypropylene film capacitors. But on the other hand, placing these capacitors as decoupling in power supply, it's just an overkill. First of all, you don't need such parameters that polypropylene film capacitors brings you in the application of decoupling. You just don't need this kind of parameters. You would rather choose just ceramic capacitor in this application. And also, other thing is that polypropylene film capacitors are still mainly available as THT elements, so through-hole components, and this also introduces some parasitics. And when speaking about power supply decoupling, when speaking about putting some capacitors of small values very close to the device that draws some current, you want to keep the leads very short, and you don't want to have any parasitics. So here this polypropylene film capacitor hypothetically could ruin the performance when dealing with decoupling application. And another very important question, but a bit tricky one, is that are audio grade parts better? Because you can also see that some manufacturers, for example Nichicon, this is a capacitor manufacturer, sells various types of capacitors. They have high durability, long life line, they have low ESR line, and also they sell audio line of capacitors. And I have a bit a problem with this kind of audio components. When I was reviewing Master Sound's Radius 4, as you may remember when you watched this film, there were some Muses op-amps. There were some op-amps dedicated to audio, and both on the Muses op-amp datasheet and on the datasheet of Nichicon audio grade capacitors, I see just statements like perfect for audio, optimized for audio, but really it's rare that any manufacturer shares some technical data. That, for example, in those capacitors we were dealing with, for example, making a dissipation factor optimize for audio. Those statements are rarely seen. Usually they just require the client to just trust them that they are just, you know, there's some kind of promise that this will be good for audio. But you as a customer are kind of unconscious what are the real qualities that makes it good for audio. So my approach is to, maybe if you like the looks or you just trust the manufacturer, you can go with audio grade capacitors, and you must take into account that of course audio grade parts are more expensive. But my way and the way I look at it is that it's nice to just have some knowledge, to just know what parameters you must consider to optimize your circuit for audio, and then across the variety of components choose the exact components that you need, and they can turn out to be not necessarily from audio line. So just being conscious and optimizing it yourself, for me it's for me it works better. And where to gain this knowledge about passive parts, and or not necessarily passive, also active parts, where to gain this knowledge to more consciously pick components. So first of all, books. Again, I'm recommending Douglas Self's Small Signal Audio Design book. It's very mind-opening, especially for beginners, because when you read this book, you now realize that you don't buy just when you, for example, want to have 100 nanofarad capacitor, you don't just buy random 100 nanofarad capacitor. You must take many things into account, and Douglas Self describe it, and most importantly he measures it, and he has done a very nice research on distortion of capacitors, and he also mentions about it in this book. Another very useful resource are manufacturer notes, because some of the manufacturers, for example, Analog Devices, Texas Instruments, those are the big manufacturers, they just publish some notes, documents, application notes, because they do their own research, and to help you with being happy with their products, to help you boost and just squeeze the best out of it, they recommend doing some things. For example, here I showed you the document that is called Selecting Capacitors to Minimize Distortion in Audio Applications. Perfect title to just read and dig deeper in this topic. And another story and another source of knowledge is your research, because it's not 100% sure that when you don't know something, you will find it in the books, and you are forced to do your research. And here, this is a very important thing to note, in my opinion, because nowadays we live in an era where we have access to ChatGPT or similar AIs, yeah, and some people think that when you ask the question, you just receive a proper answer, because ChatGPT has just all the human knowledge available, and he will just give you a proper answer. I obviously use ChatGPT. It's very nice for just, you know, to be creative, to just come up with some ideas, to make some research, but I never trust ChatGPT. I always check it, and really it's very often for me to receive information from ChatGPT, and then it turns out to be false. Because the problem is that Technically, that's true that ChatGPT has access to whole knowledge of humanity, but in his database, he has also some internet forums, some opinions, you know, the learning material for this AI is not 100% legit, and chat can you tell some things that will be simply false. So really be careful with ChatGPT when discussing making of a DJ mixer. Some of you wrote to me, and I had a really nice and insightful discussions on a Facebook group I opened, the Mixers Inside Facebook group. And sometimes people just mentioned that why not asking ChatGPT? Why not just, for example, for circuit analysis? When you don't understand the circuit, you can just paste an image for analysis for chat, and he will tell you everything. But it turns out that it's really often that he just doesn't he. I humanized ChatGPT, that this AI is not right, that it gives you an answer and it sounds clever, but when you really listen to it, you can sometimes be in serious trouble. So just be careful. And now I want to present you a bit of my research on example of my mixer, because now we are speaking about this guy. Yes, making of a DJ mixer series will end someday, and the fruit of this series will be a fully functional mixer. I think it's very nice and beautiful. I'm proud, really. And I want to share you some example of my research and how I pick passive components in one application. And for example, I want to give you EQ circuit, obviously from Array 1620. This circuit was discussed by me on previous episode when we were talking about the circuitry. And here this circuit is placed on my board. The arrow shows exactly where this EQ circuit is. So let's take a closer look, and let's discuss what components I used and what components I considered that will be just suitable for this application. Speaking about potentiometers, I chose Alpha Taiwan brand potentiometer. This is just a medium-sized pot, and it's also medium quality pot. It's not the cheapest one, it's not the most expensive one. I have pretty good experience with Alpha Taiwan potentiometers, because back in 2019 I built my first rotary mixer, so now it's like 6 years from building it, and I was using it quite regularly, and those pots didn't disappoint me, and also they have quite nice feel. They are not very loose. They have some rotation resistance. So that's why I chose Alpha Taiwan, but you can also consider placing Alps potentiometers that are a bit more expensive, but the reason is the reason why I didn't go with Alps here is that I'm not entirely sure that Alps will bring quality benefit, but it's to be examined. But I didn't really dig deep into it. The main reason I chose those alpha potentiometers here were just size. It was just size, because when speaking about potentiometers, you want to take into consideration also just shaft length, and just you know, the physical size of the shaft, and also there are some types of shafts. There are D shafts, there are flat shafts, knurled shafts, and this potentiometer, this alpha potentiometer, was just perfect for me in terms of sizing, and I found just a nice source of those potentiometers, so I just got them, and eventually when I'll find in the future something that is better, I will change it, but for this application I think that it's just okay. Medium quality pot, and the worst thing that can happen, and it's also worth mentioning, the worst thing that can happen when you use lower quality potentiometers is first durability. After use, low quality potentiometers after shorter use will become scratchy. You will hear audible scratches, and you will have to replace it sooner. Also, cheaper potentiometer tend to have worse channel trackability, stereo channel trackability. It's called gang error, and it means that when you deal with stereo signal, you use mostly dual potentiometer, so with two tracks to deal with left and right channel. And when you turn the knob and set it in a certain position, cheaper potentiometers can have variation between channel volumes. That, for example, left channel can be 3 dB louder than right channel. Potentiometers can introduce such unbalance. And so yeah, the worst thing we can expect from a cheap, lower quality potentiometer is that it will be less durable, that it will have bigger gang error. Also, lower quality potentiometer will worsenly attenuate the signal, and they ruin so-called offness. So like the amount of attenuation achieved on the fully attenuated position. But, and this is very important and worth mentioning, potentiometers don't ruin the linearity and the sound quality in terms of distortion, because I came across some opinions. It's really I really came across some opinions that, for example, changing potentiometer from one to another can make the sound cleaner, or reduce the distortion. With potentiometers you can't achieve it. It's not the case. So, for example, also when you have so-called rotary conversion, when you have a mixer with faders and you change it to Alps Blue Velvet potentiometer, quite expensive one. When you change the fader with Alps Blue Velvet, you can expect that yes, you will get rotary conversion. Maybe you'll achieve less gang error, but it's not guaranteed. But definitely it will not change the sound character of your device. Potentiometer don't do this thing. So yes, I think it was just important to mention. So let's jump to another component I used in this EQ circuit, and that I'm extensively using, resistors. When I was picking the resistors, I wanted to have a stable value, tight tolerance, and I wanted them to be quite small, and I think that very nice quality resistors are minimal type. You can see it in the image. They have low ppm, and this is this thermal coefficient I was mentioning before, and this low ppm essentially what it describes is that how sensitive your resistor value is to change in temperature. So how how your nominal value changes according to changes in temperature. So when you deal with very low distortion circuits, and I also showed you a couple of slides before this experiment from Texas Instruments, when they were comparing thick film external resistors and internal thin film resistors on chip, that those thick film resistors were limiting the performance. Where using low ppm resistors, you have less risk of resistors ruining the performance, but it's worth mentioning that you must really take care about it when dealing with low distortion circuits. When you deal with circuits like minus 60 dB of THD, when you deal with circuits that have just a significant amount of distortion or noise, you don't really have to take much care about resistor quality, because it will the effect of this resistor will just flatten those distortions and noise generated by active components and just circuitry. But when you want to make things more clean, transparent, get down with distortion, like the more you get down with distortion, the more pronounced impact those passive components have. So yeah, those minimal type have technology that allows them to be low ppm. They have tight tolerances. I use resistors that have 1% of tolerance, and I think that it's perfectly enough. And they're also made in thin film technology, and thanks to thin film technology, their internally generated noise by this resistor is also lower comparing to other types, for example, thick film. And next thing is IC op-amp. Integrated circuit op-amp, and here we have this classic TL084 that was used in original array, and also a very common chip TL072 or 74 is used in many mixers. But what I did here is to be faithful to original, I used THT package of this op-amp. I used deep 14 package. I didn't use a small outline SMD part. I used a bigger part because I wanted to use exactly the same chip that was used in original array. So I paid the cost because it takes more area in the PCB than SMD part, and also it can introduce some parasitics, but in array design, which doesn't have high bandwidth, is generally, let's call it slow. It doesn't have, it's not super fast high bandwidth circuit. So here I wouldn't worry really much about parasitics, so I went with a larger package just to be faithful to the original. This is not really not very scientific decision, but I wanted just to stick to original this way. Another part here visible is low value capacitor used in the filtering circuit, and here this 820 picofarad capacitor is used in the EQing circuit. It helps to filter the frequencies, and I used type tolerance NP0 type ceramic capacitor. Because of small value, I decided to go with ceramic small size capacitor and NP0 type. This is very important because ceramic capacitors are also X5R or X7R type, and they're completely not suitable to this application because their value can change with applied voltage, so they present nonlinear behavior, and also ceramic X5R and X7R ceramic capacitors can suffer from a piezoelectric effect. So essentially, when you have some vibrations or you just push, you know, like how to say, you know, like push the capacitor, it can be actually audible due to piezoelectric effect. So yeah, this low value type, low value capacitor, I chose ceramic NP0 type. Also, I took care about tight tolerance because it works in the filter circuit. So I want to tolerance to be tight to just stick to the time constants that were just in the design. And another capacitor, because now I will tell you a couple of words about various types of capacitors. Here we have capacitor that also works in the filtering circuitry, but what's different from previous capacitor I showed you is that it has larger value. Previous capacitor had 820 picofarads, and this capacitor is 18 nanofarads, so much larger value. And here I went with polypropylene film capacitor, MKP. I went with polypropylene film capacitor because, first of all, it's very stable. It also it's not non-linear. It doesn't cause signal distortion, or a very small amount compared to other types. And also polypropylene film capacitors are available in tight tolerances, and this is also important. Another capacitor I want to show you here is a capacitor used here for DC coupling. The role of the capacitor here is not filtering. The role of this capacitor is to block DC from entering the next stage, to keep the DC level near zero. And here I use electrolytic bipolarized capacitor in contrary to original array, because original array uses just regular polarized capacitors. But I saw many people upgrading original array with those bipolarized capacitors, and in this application, when placing a capacitor in the signal path and blocking DC, it's more advisable to use bipolarized capacitor because it's symmetrical. So when you have just current flowing both ways, when current is flowing both ways, you want to have symmetrical behavior, and polarized capacitor represents less symmetrical behavior, and it can introduce some non-linearities and distortion. And another example of a capacitor in this circuit, this is a capacitor used for power supply decoupling. This capacitor role, and it's not seen here in the schematic, but this capacitor role is to be a local small power bank for a nearby chip. So it's completely different application than filtering or DC blocking. This capacitor role is to just store some charge to provide some current in cases where the nearby chip needs some. So, and in this application I use just regular electrolytic capacitor. Here we don't have to care about this symmetry I told about, because this capacitor is just across power rails, so it's like constantly polarized by one of the power rails. So regular electrolytic here in this application is perfectly fine. Now, what I want to mention also is in terms of part selection is volume pot, because now we are still more or less talking about making this design, making my design close to Array 1620, and the thing that Array 1620 use, and it's really a standout, are those big, really big ALPS potentiometers for channel volume control and also for main volume control, basically for volume controls. Those are called ALPS RK40. Those are also called Black Beauty potentiometer, and they were used in original Array 1620 and Bozak mixers, but the problem is that they are no longer produced. They are just unavailable. You can buy some new old stock for insane prices, but those pots were very durable. There are some Array mixers that have some they were running for like 20-30 years, and those pots are still fine. So yeah, they are just solid. I don't know why Alps didn't reissue it. I think that if they reissue Black Beauty pot, there will be demand, but maybe this market, this high-end audio market, is too small to force Alps to produce such pot. But they came up with equivalent. Here we can see modern replacement. This is commonly known Alps Blue Velvet pot. You can see it almost in every mixer out there, especially in volume application. This is called Alps RK27 or 271 also. I think that more recent name is RK271. Yeah, as I mentioned, it's used in most of modern rotary mixer, and it's cheaper than RK40, and most importantly, it's available. You can just buy it new, you can get it, so it's just available. So this is a big plus. And you may ask why all the mixers use Alps Blue Velvet potentiometers, and why especially it's used in volume applications. Oh, okay. Sorry, I will mention one very important thing here. I forgot about it, and it's something I really want to show you, because there is a myth about those discontinued Alps RK40 potentiometer, and myth about Array and Bozak mixers, that the thing that made them sum so well was also the curve of the potentiometer. So it was by the curve I mean the gradual how to say it. It's how this potentiometer attenuate the signal according to the rotation. And there was a myth that RK40 had some special curve, and this made summing in Array and Bozak super special, and that it's not to be made with modern equivalent. And this is the part where I couldn't find it in any book. I couldn't ask ChatGPT if it's true. There was just an opinion going out in the web. So what I did, I just measured both potentiometers. I had opportunity to service Array 1620. I measured the curve of Alps RK40. I measured the curve of Alps RK27, even in two mixers. I measured Alps RK27 used in Condesa mixer, and I measured also Alps RK27 used in my mixer, and I compared the curve with legendary RK40, and those are the results. Suspense. Do you see it? I can say that the curves of old RK40 from Array and modern RK27 are just identical. So I guess that this myth is busted, but if you know about any source of this myth, or there is something that can confirm this myth and tell that my measurement or my research is not exactly true, please get in touch with me or comment it in the comment section, because I'm really curious about this myth. But as far as I did the research, it's essentially busted. Modern Alps RK27 and RK40 have just the same curve. And yeah, the thing I wanted to say before, but I just was saying about this curve comparison, I will want to also give you some views about why people so widely choose RK271 and why it's mostly used for volume applications. As you can see from the datasheet, I compared the RK163 model. This is a quite commonly used model in some EQs, but you rarely, in some rotary mixers, you rarely see this smaller RK163 in volume application. You more often see RK271, and the difference is not actually durability. They have exactly the same operating life stated by manufacturers, and it's 15,000 of cycles. And what differs RK27 or 271 is the feeling. It has more resistance when rotating it, but also it has a better gang error. This thing I was talking about previously, this difference between two channels. In RK163 we can see that the maximum gang error between channels from -40 to 0 dB attenuation is 3 dB, and then with RK271 we get it better by 1 dB, and also across higher range of attenuation, because from also -60 dB, not from -40. So yeah, RK271 has better stereo tracking, it has this feeling, but the operating life is essentially the same. So it's a very popular, widely used spot, and the question is why people are not using some alternatives. There are some alternatives, and there is one really strong alternative, but it's 4 times more expensive. But for example, there is a company from Japan, it's called TKD, Tokyo Koon Denpa, and this potentiometer is essentially manufacturer call it conductive plastic attenuator, and it uses conductive plastic technology. And look at the life of this potentiometer. This potentiometer has life of 100,000 cycles. When we are looking at Alps data, it was 15,000, and here we have 100,000 cycles. So it's much more durable, and also it has even better gang error. This 1 dB is stated from -10 dB to 0 attenuation, so at the very end of the range, but still this potentiometer has even better gang error than Alps. So yes, there are some alternatives, but they are just more expensive, and you must just pay the price for better performance. And as I see, I don't know any manufacturer that actually used those TKD potentiometers. All manufacturers still use Alps. Yeah, so now ending the potentiometer, ending speaking about potentiometers, I want to talk a bit about the biggest challenge with cloning Array 1620. Obtaining Alps RK40, it's not the biggest challenge, because I show you the curves I measured. So I don't really need this vintage potentiometer to achieve the curve that will guarantee me a better summing or something. This is not a very big problem. I will take the standard Alps RK27 that is available from the shop, and problem is just solved. But the problem of output transformers that are present in array is very hard or nearly impossible to solve. The reason is that those transformers are no longer produced, and there of course are some alternatives, but those transformers are not identical, and taking the transformer out of array, measuring it, and copying it somehow, I think it's possible, but it's very difficult, mainly because of the core material. Every transformer has its own core, and this core is a specific mix of some metals. And to achieve exactly the same core as an array transformer, I would have to order some cores from specific metal types and stuff, and I think that ordering, I did a small research, and also if you have something to add, please tell me something about it, but I did a small research, and to actually produce some transformer cores that will fit your specification, it's an investment of hundreds of thousands of dollars or even millions of dollars, because a factory must receive a bulk order from you and produce a lot of cores. It's not possible to just call the factory and say, oh, okay, I need to just make even 100 transformers. They provide it in much more volumes. So this problem is quite a challenge, and it's quite a challenge because also output transformers in array are responsible for array signature sound. Output transformers are something that make array sound like array. You can find some resources on the web, what are the reasons why transformers are liked by audiophiles, but also by sound engineers, because when you have transformers in the circuit, they can just dampen some transient, then they can give you some color, and thanks to this you can achieve fatter sound in low end, and also you can achieve some glue and summing the signals. This transformer saturation is desirable when sound engineers are searching for glue. And to be honest, I don't have any brilliant idea how to clone the output transformers, so I will probably have to buy some modern transformers, compare them, and see what will be most suitable. But I have some inspiration, because there are some mixers already in the market that are more or less array copy. I also spoke about this on previous episodes, and those mixers that copied array solutions are, for example, E&S DJR400. This is a quite known mixer, and also Alpha Recording System from Japan. And this is an example how Alpha Recording System company solved the problem of output transformer, because as I said, this design is heavily array inspired, but they just solved output transformer problems in modern way. They just used balanced line driver chips. This is nothing new. People that were watching my video series saw those parts before. those balanced line drivers were used, for example, in master sounds mixers. They used that corporation chips. Here we can see chips by Analog Devices. So essentially what ARS did is that they replaced output transformers with active circuitry. They used just balancing chip. As far as I know, ARS mixers are really praised for their sound, and they don't have any transformer in the signal path. They used just electronic balancing, and I guess it also sounds nice, but for sure getting the transformer into signal path can further help to squeeze more fatness out of high-end, I believe. Yeah, so to end this presentation, that was already quite long, I want to recommend you some sources where you can buy electronic components, and also I want to warn you from buying electronic components from China, especially from portals like AliExpress, because there are a lot of fake components. When you buy parts from China, you don't have really control, and if you think you bought branded part, for example, when you think that you ordered Alps potentiometers from China, it can actually turn out that it's fake, it's not from Alps. Or when you buy some semiconductors, when you buy some chips, you buy some chips from China and they just can be fake, and there were some cases that Chinese people copied, for example, classic audio chip 5532 op-amp, and on the internet forums, on the web, you can find some research on this, where someone actually just scrapped off two op-amps, original and fake, and analyzed the internal structure, and it was very obvious what chips were fake, and unfortunately fake chips had worse performance. So I recommend buying electronic components from official sources. Here are free shops that I personally used. I don't want to suggest you any particular shop to first of all, this is not a commercial of the shop, and second of all, it just depends on what you need, and also on the prices, because on some shops you can find some components that you won't find on another shop, so you are forced to buy from this shop. And when you have the same component available from free shops, you can go with the price criteria and just select the shop that offers the cheapest option. But yeah, when buying from official distributors, you are just sure that this component is genuine, and thanks to this, you can be assured that it will stick to stated performance by manufacturer, and this is just super important. So yeah, thank you for watching this presentation. I'm very excited to show you circuit board design in the next episode. I'm also excited to hear out from you, because I was discussing a lot of topics and maybe you have something to add. And also I invite you to join mixersinside Facebook group, because already there are some interesting discussions, interesting photos of internals, and it would be perfect to just have more people joining and also posting photos and measurements of their own mixers. You can also on this group share your designs and just inspire others, or seek for help. There are also people on this group that are starting to build a mixer. They ask some questions and they receive answers. And remember that there are no dumb questions. On this group, I will be very happy to help. So yeah, once again, thanks for watching this, and see you next time.